In our previous session, we mastered the sample pretreatment of Spatholobi Caulis in its reference material, obtaining both test and reference solutions. Then how can we perform standardized operations to achieve optimal thin layer chromatography (TLC) spectrum? Now, let's explore the TLC techniques for Spatholobi Caulis. It includes the following 6 steps. First, selection of thin layer plate. Second, preparation and pre-saturation of developing solvent. Third, spotting. Fourth, development. Fifth, visualization and inspection. Sixth, recording. The instruments and reagents used in this experiment include thin layer plates, spotting capillaries, spotting heater, developing tank, visualization device, triple-purpose UV lamp, as well as reagents like methanol, formic acid, dichlominatin acetone, and 5% vinyl sulfuric acid solution. First, selection of thin layer plates. Commonly used silica gels in layer plate include silica gel GN Select at GF254, where GF254 indicates the addition of a fluorescent agent that displays a green background under ultraviolet light at a wavelength of 254 nm. Generally activate at 110 Celsius for 30 minutes before use, then store in a desiccator for subsequent use. Shooting process, drawing the origin point. Draw the baseline and the spacing between samples with a pencil, keeping the baseline 10 to 15 mm from the bottom legend. The origin spacing is no less than 5 mm. Second, preparation and pre-saturation of developing solvent. Using a mixture of dichlominate and acetone methanol formic acid as developing solvent in a ratio of 8 to 1 to 0.3 to 0.5. Note that multiple developing solvents should be prepared, with each solvent measured separately before mixing. Small volumes of solvents should be measured using a pipette or volumetric pipette. Mixed uniformly in a reagent bottle before being poured into the developing tank and pre-saturated for generally 15 to 30 minutes to avoid the edge effect. Third, spotting. Place the activated silica gel GF250 for thin layer plate on the heater, between 40 degrees Celsius and 50 degrees Celsius. Pipette 5 microliters each of the pre-prepared Spatholobi Caulis Patholobus stem reference material solution and subirect Spatholobus stem test sample solution, and spot them separately on the thin layer plate. The distance between two spots should preferably be between 1.0 cm and 1.5 cm. Note that spotting should be performed in small amounts and multiple times, allowing it to dry before repeating the spotting. The diameter of the circular spot should not exceed 4 mm. Additionally, the spotting pipette should not be used interchangeably. Fourth, development. Place the thin layer plate spotted with reference drug and test solution into the developing chamber, immersing the plate in the developing solvent to a depth of approximately 5 mm from the spotting baseline. Ensure proper sealing by applying an appropriate amount white petrolatum on the cephalogy to enhance the chamber's air tightness. Generally, the ascending development is carried out for between 8 cm and 15 cm. After reaching the specified development distance, the thin layer plate should be immediately removed, air-dried, and the developing solvent poured into the waste ball. Fifth, visualization and inspection. Generally, spots with inherent color can be directly inspected under daylight. For substances that fluoresce under ultraviolet light excitation, fluorescent spots can be observed under UV lamp, 250 for nanometers or 365 nanometers, if the spots cannot be directly inspected after visualization. A suitable chromogenic agent or heating may be used for visualization, and then inspected under visible or ultraviolet light. Thin layer chromatography identification of Spatholobi Caulis is first inspected under ultraviolet light, 250 for nanometers. In the chromatogram of the test sample, spots of the same color appear at positions corresponding to those in the chromatogram of the reference materials, then spray with a 5% vonolyl sulfuric acid solution, heat at 105 degrees Celsius until the spots become clearly visible. At corresponding positions on the chromatogram of the reference medicinal materials, spots of the same color can be displayed. Sixth, recording. Thin layer chromatography images can generally be captured using photographic equipment saved in the form of optical photos or electronic images, or scanned with a thin layer chromatography scanner, or recorded by other suitable methods to obtain corresponding chromatograms. How to determine the TLC results of Spatholobi Caulis, a lobus stem obtained in this experiment? If spots of the same color appear at the positions corresponding to the reference medicinal material chromatogram, it is evaluated to comply with the standard. Let's briefly review what experimental steps we learned today. First, selection of thin layer plate. Second, preparation and pre-saturation of developing solvent. Third, spotting. Fourth, development. Fifth, visualization and inspection. Sixth, recording. What are the precautions that need to be taken? First, the sample spotting amount on ordinary thin layer plates should be controlled within 10 microliters. Excessive sample spotting may cause overload and easily lead to tailing of spot. Second, the developing solvent should be pre-saturated to avoid edge effect. Third, prepare multiple developing solvents by measuring and mixing various agents separately. Small volumes of solvents should be measured using pipettes or volumetric pipettes. Fourth, developing solvent should not immerse the spots during development. Chinese medicinal materials are an important part of China's profound cultural heritage. The development of modern identification technologies for Chinese medicine can help us better inherit and disseminate traditional Chinese medicine ECM culture, ensuring the safety and efficacy of Chinese medicinal materials. Moreover, these technological advancements also serve as key catalysts for industry transformation, enhanced global competitiveness, and standardized quality assessment in herbal medicine. We must uphold rigorous scientific standards and maintain an innovative spirit through persistent exploration in medicinal identification, advance the development of modern identification technologies for Chinese medicine, and make greater contributions to the quality control and drug RD of Chinese medicinal material. That's all for today's session. See you next time.